Hello everyone. I'm going to go through the binomial expansion. Get started with the first question. Consider the binomial expansion x plus 1 whole to the power of 7 is equal to the expansion is given here, right? So let us read the question carefully. Where x is not equal to 0 and a and b belongs to positive integers. So these are integers, positive integers. Okay, show that b equal to 21. Okay, so let's see that b equal to 21, so which means this one, third term, right? So third term means I will start with, so you can also see here the clue is given. If the a term is 5, so the r is going to be 7 minus 5, which is 2. So 7c2 times x to the power of 5 times 1 to the power of 2. 1 to the power of 2, basically you don't need to write, but let's just write it, is equal to, we need to find what is that b. Okay, so this is basically a paper 1 question. So I'm going to use the formula. So 7 factorial 7c2, how can I write 7c2? 7 factorial divided by 2 factorial times 7 minus 2 factorial, which is 5 factorial. Okay, so I'm going to expand this. So 7 factorial, I can write it as 7 times 6 times 5 factorial over 2 factorial times 5 factorial. So now we can cancel the 5 factorial, and 2 factorial is nothing but 2. So 2 times 1 and 2 times 3. So b is basically 21. So this was b x to the power of 5, right? X to the power of 5. So b is basically 21. So we have shown already b is 21. This was part A. Now let us see part B. The third term in the expansion is the mean. The third term in the expansion is the mean of the second term and the fourth term in the expansion. Find the possible values of x. Okay, so basically you have to understand the third term, which means u3 is equal to u2 plus u4 divided by 2, because he said mean, right? So let us see, let us find first all the terms, then we are going to solve for x. Okay, so how do I write second term as, I'm going to write the second term as 7c1 times x to the power of 6, because 7c1, first term is 7c0, second term is 7c1, right? So I'm just ignoring the 1, because 1 to the power of anything will give us 1. So I'm just ignoring 1. So I'm just writing it as, only I'm taking the first term of the expansion, right? So 7c1 is 7 and x to the power of 6. And the third term, let us find in order, all right? So third term is, how do I find third term? 7c2 times x to the power of, if the r is 2, remember, you have to relate everything. If r is 2, the a is going to be 7 minus 2, which is 5. So what is 7c2? 7c2 is going to be, I think we found the 7c2, the third term already here, which was 21 x to the power of 5. And the fourth term, so fourth term is going to be 7c3, right? Times x to the power of 4 is equal to 7c3. You can just use the formula 7 factorial divided by 3 factorial times 4 factorial. So this gives us 35 x to the power of 4. So now let us look at the condition here. What does the condition says? u3 is equal to, which is 21 x to the power of 5 is equal to 7 x to the power of 6 plus 35 x to the power of 4 divided by 2. right? So whenever there is a fraction, we always cross multiply. So I'm going to divide this one into two parts because we don't have much space. So 7x to the power of 6 plus 35x to the power of 4 is equal to 42x to the power of 5. So I'll bring all the terms together. So 7x to the power of 6 minus 42x to the power of 5 plus 35x to the power of 4 is equal to 0. So now I'm going to factorize. So I can take 7x to the power of 4 as common. So now this gives me x squared minus 6x plus 5 is equal to 0. Now I'm going to factorize this. I can put it this one into the two brackets. This gives me x minus 5 times x minus 1 is equal to 0. And don't forget this 7x to the power of 4 also. So I will get x equal to 0 and x equal to 5 and x equal to 1. So these are the three values of x. You can see that the question said possible values. So which means we have many values of x. So that is the clue. Always we have to look for it. Okay, so there are three values of x. Let's go to the next question. How many marks was this question? It was a 7 mark. Wow. Right. So let's go to question number next question. So in the binomial expansion 1 plus kx to the power of whole power n is given by 1 plus 9 x over 2 and so on, right? Where n is positive integer, we know that n is always a positive integer and k can be a rational number. Q means rational number. Okay, so let us see. Let us find the value of n and the value of k. So according to the question, you can see that we have the second term and the third. So using these information, I'm going to form two equations. Okay, so the first one is second term. How do I find second term? NC1, right? First term is NC0, second term is NC1 times. Let us just ignore again this 1 because 1 times anything just gives us 1 only. So kx is equal to 9 over 2x. Because see, the b term always follows the r. So this is basically to the power of 1. Is it okay? Then what is NC1? NC1 is just n. We know that NC1 is just n. So nk is equal to 9 over 2 because the x gets cancelled. So I can write this one as n equal to 9 over 2k, right? This is the first, we got it. Now let us see this third term. Here is the third term. So how do I find third term? NC2 times, I'm just ignoring the 1 again. So then it's going to be kx whole square is equal to 15k square x square. So what is NC2? NC2 is nothing but n factorial over 2 factorial times n minus 2 factorial, right? Is equal to, so this one also k square x square is equal to 15k square x square. So again here k square x square I can basically cancel it, right? So now let us expand this. N factorial I can write it as n times n minus 1 times n minus 2 factorial divided by 2 factorial times n minus 2 factorial. So this n minus 2 factorial and minus 2 factorial, I can cancel it. So n square minus n is equal to, I'm cross multiplying 15 times 2 is 30. So I will bring the 30 inside and now I can factorize. So this gives me n minus 6 times n plus 5 is equal to 0. So n equal to 6 or n equal to negative 5. So since n it belongs to, here the question gave n belongs to a positive integers, so n equal to 6 only. We have to consider only n equal to 6. So that n I'm going to put it here into the equation and solve for k. So n is 6, 6 equal to 9 over 2k. I cross multiply, 12k is equal to 9, k equal to 9 over 12, which is 3 over 4. So once you get both the values, it is better to write it down. The value of n is equal to 6 and the value of k is equal to 3 over 4. In the DP, always it is better to write the final answer at the end. Okay, let's go to the next question. The next question is 5 marks. 5 marks means maybe it is not that hard, but let us see. Consider the expansion of expansion of 3 plus x square whole to the power of n plus 1, where n is again positive integer. Given that the coefficient of x to the power of 4 is 20,412, find the value of n. Okay, so x to the power of 4, which means you can see that this must be the b term must be x square whole square. Then only it can become a x to the power of 4. So which means n plus 1, because now n is n plus 1. N c, it must be 2 because our r must be 2 here. So if r is 2, I'm going to write it as 3 to the power of n minus r. So what is n? N is n plus 1 minus r. What is r? R is 2 times x square whole to the power x square whole square is equal to 20,412 x to the power of 4. So we can basically ignore this x to the power of 4. So now let us expand this n plus 1 C2. How do I expand n plus 1 C2? Let us see. So n plus 1 C2 is n plus 1 factorial over 2 factorial times n plus 1 minus 2 factorial. Because what is the formula? N factorial over r factorial times n minus r factorial. Then times 3 to the power of, I'm going to simplify this becomes n minus 1 is equal to 20,412. So now let us expand this. So n plus 1 whole factorial, I can write it as n plus 1 times n, then times n minus 1, then factorial over 2 factorial, and this becomes n plus 1 minus 2 becomes n minus 1 factorial. So now I can cancel this times, don't forget this to write it, 3 to the power of n minus 1 is equal to 20,214. So I'm going to expand this now. So n square plus n is n times 3 to the power of n minus 1 is equal to, I'm going to cross multiply. This gives me 40,824. 40,824. Then this is a paper 2 question. So to solve this, use calculator. How do we use calculator? We go to the menu, and in the menu you can choose the equation solver, and then once you press the equation solver, go to the menu, then from there equation solver and press F3. So put this equation into the calculator, put this equation into the calculator, and you will get n equal to n equal to 7. So the answer is n equal to 7. Let's go to the next question. Question number 6. Consider the expansion of ax plus 1 whole power 9 over 21x to the power x squared, where a is not equal to 0. The coefficient of the term x power 4 is 8 over 7, a to the power of 5. So find the value of a. So you have to see that this whole term, the whole term, the coefficient of x power 4, which means the numerator must be x power 6 because we already have a denominator as x power 2. Then only we can get x power 4, right? So we need to work for x power 6 term in the numerator. Okay, so if the first term is 6, so it is basically, if the first term is 6, so the r will be 9 minus 6, which is 3. Again, we have a 1, we can basically ignore it. So divided by 21, x to the power of 2 is equal to 8 over 7, a to the power of 5. And this is also x to the power of 4 term, right? Now you see what is 9c3? 9c3 is, this is a paper too, so basically you can use calculator. 9c3 is 84 times a power 6, x power 6 over 21 x power 2. Now you see x2 and this becomes 4. See, right? Then 21 times 1, 21 times 4. So this gives us 4a power 6. X power 4 is equal to 8 over 7 a power 5 x power 4. So I can basically cancel x power 4. So this gives me 4 a to the power of 6 is equal to 8 over 7 a to the power of 5. So I can cancel a power 5 and this 6. So 4a is equal to 8 over 7. A is equal to 8 over 7 times divided by 4 on both sides, right? So answer is 2 over 7. If you change this one to 3 significant, first let me write a calculator display, then I will change to 3 significant. 8286 as 3 significant. So the value of A is 0.286. Question number, next question. The coefficient of x to the power of 6 in the expansion ax cubed plus b whole power 8 is 448. And the coefficient of x power 6 in the expansion, you can see they are not same, the powers are different. This is whole power 10 is 2880. Find the value of a and the value of b, where a comma b both are greater than 0. Okay, so let us see. So in this you can see that it is x power 6, which means this must become x cubed times whole power 2. Then it becomes, there is some problem with my iPad pencil. Just give me a minute. No charging. Yeah. So you see, this gives me x power 6, right? Similarly, even this x to the power of 3 whole square gives me x power 6. So now try to understand. So this gives me 8. If the first term is 2, what should be the C? What should be the R? 8 minus 2, which means 6, right? then times b power 6 is equal to 448 x power 6. Similarly, 8 power, same thing. Now, the 8 power 6, what is 8c6? Not 8 power 6, 8c6. 8c6 is nothing but 28 a squared x power 6. b6 is equal to 448 x power 6. So I can simplify this. 28 times 1 and 28 times 16. So this is 16. Now I can write it as a squared b6 is equal to 16. So this is the first equation we got. Now let us find the second equation. Second equation 10c6. This one also same sixth x to the power of 6 quotient of x to the power of 6. So it's going to be same 10c6 times ax cubed whole square times, this is going to be, sorry, this is 10. So we need to look for, if this is 2, r is going to be 8. So b to the power of 8 is equal to 2880 x to the power of 6. So what is 10c8? 10c8 is 45 times a squared x power 6 times b to the power of 8 is equal to 2880 x power 6. So I cancel the simplify x power 6 gone. Then 45 times 1, 45 times 64. So this becomes a square b8 is equal to 64. So this is the second equation. So now I'm going to put them, I'm going to solve for b now. So a squared b a power 8 is equal to 64 divided by a squared b6 is equal to 16. So a squared gets cancels. This gives me b squared. B squared is equal to 64 over 16 is a 4. So b equal to plus or minus 2, but we need to take only 2 since the question said a and b are greater than 0. Okay, so once I get the a value, b value, I'm going to solve for a now. So a squared times 2 to the power of 6 is equal to 16. A squared is equal to 16 over this 2 power 6 is 64. So 16 over 64. So A is equal to, again same thing, times 1 times 4, 1 over 4. 1 over 4 can be, square root of 1 over 4 can be plus or minus 1 over 2. But again, A must be greater than 0. So I will take only a equal to 1 over 2 only. So once we get the values of a and b, I will write it down. The value of a equal to 1 over 2 and b equal to 2. So these are our final answers. So the last question in this worksheet, this is the last question. The expansion x plus h to the power of whole to the power of 8, where h is greater than 0.89 is going to be 0.05. Now for this one, probability of z greater than 140 minus 120 divided by 24. Probability of z greater than 0.8333. So 1 minus probability of z less than 0.8333. So I'm going to check this value, 0.20 divided by 24. Then I'm going to find that from the table.
and 0.833 value, 0. So it's going to be 1 minus 0.7975, 0.7975, which is going to be 0.2025. Now this is also 0.2025. So when I see this one, I got it out 90 and 140. 90, 120 and 140. Now this is 0.2025 and this is also 0.2025. Now what am I going to do that? 1 minus 0.2025 minus 0.2025. So 1 minus 2 times of the answer. So coming to question number 5. The weights of the apples sold by a store are modeled by normal distribution. Mu equals to 120 and standard deviation equals to 24. Now 90 grams are modeled as small, less than, and more than 140 grams are modeled as large. And the remaining are medium. Show that the probability of the medium is this one. So probability of anything lying between 90 and 140 are called as medium. So probability of x less than 140 minus probability of x less than 90 by 90 is going to be the answer. So z less than 140 minus 120 by 24 minus probability of z less than 90 minus 120 by 24. So this is probability of z less than 0.833 minus probability of z less than this will become minus 1.25. So probability of z less than 0.8333 minus 1 minus probability of z less than 1.25. So this value is going to be 0.7975 minus 1 plus 0.8944, which is going to be the answer 0.6919. The significant figure 0.692. That's going to be this question. Now part 2. 4 apples are chosen at random. Find the probability that at least one is graded as median. So at least one, at least two, not one, at least two. So probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4. So 4C2, 0.692 is a success. 1 minus 0.692 whole to the power of 2. So 4C3, 0.692 whole to the power of 3 and 1 minus 0.692 is, if at all I write like this only, better, whole to the power of 1. Then 4C4, 0.692 whole to the power of 4. Then 1 minus 0.692 whole to the power of 0. 0.27256 plus 0.